my dear students to VTeach. Today in this video we are going to discuss about the properties of regular sets under flat unit 2. Now enter into the topic. The first property is like this. The property is the union of two regular sets is regular. How we can say that the regular expressions are of the sets is in regular under union property. Look into the definition and the example. They are like this. As a proof, now we are going to consider two regular expressions like this. RE1 as A of AA whole star and RE2, that is regular expression 2, as AA whole star. So consider the language 1 under the expression as L1 as A triple A 5 A's, which is nothing but the odd length excluding null, that means strings of odd length. And consider the L2 which is having the epsilon, that means the null set, and the even length strings, that means the length of strings are of even including null. Now what we are going to do, the union of these two will give the result as the odd strings along with the even strings combined with epsilon. So strings of all possible lengths including null, we got the result. So therefore what we can say, the regular expression of L1 union L2 is given as A star, which is the regular expression itself. That means A star is the regular expression itself. So the union of these two regular expressions is under regular. Now the next property, intersection of two regular expression is regular. Now as it is, consider the same example that what we considered in the previous one as RE1, RE2 like this. So the L1 which is defined on the regular expression 1 is of odd length strings and L2 is of even length strings. The only difference between those two is in odd there is no epsilon, that is empty set, that means null set. That means here in the even we included the null. So the intersection of these two given as like this, which are having length of even excluding null. So regular expression on the intersection of two languages is given as AA of AA whole star. That means see here AA is there, here AA are repeated, which we can say that AA whole star. So intersection is also under regular, so we can prove it. So the next property, that is the third property, is defined like this. The complement of a regular expression is regular. How we can consider it? A regular expression is of the form AA whole star. So language L is defined as the even length strings including the epsilon, that is null string. So next, the complement of L is defined as L dash. Then the complement is considered like this, that means with odd strings. That means the given language under the regular expression is of even strings and the complement is given as the odd strings. So consider that the regular expression which we can define on the result, that means the complement of the language, is like this: AA star, AA star, like this we define. So the resultant regular expression is of the form A of AA whole star, which is under regular. And the fourth property is like this: the difference between two regular sets is a regular. Now consider another regular expression like this and like this, that means two regular expressions. Now we are going to take the difference between the two regular expressions after converting them into languages. For the first one, the language is like this, which is of possible length of strings excluding null. Whereas for the next regular expression, the language is like this, that means even length strings including null. Then the difference between these two is like this. See, A, triple A, 5 A's, 7 A's. So what we got? We got the strings of odd length excluding null. So for that one, define the regular expression. We can see whether we can define the regular expression on the result or not. If we can define the regular expression, then we can say that it is regular. That means the difference is regular. Yes, here we got the resultant regular expression for the difference between two languages is like this. So which is under the regular. That means the resultant expression is also regular. And the fifth property, the reversal of regular set is regular. That means the reversal process. Now consider a language which is having the strings as 0, 1, 1, 0, 1, 1, 1, 0. Then regular expression of L is 0, 1, 1, 0, 1, 1, 1, 0, which is with plus. So then L of R, that means LR, which is the reversal of the language, is defined as reversal of this one is this. That means 0, 1 became 1, 0, 1, 0 became 0, 1, 1, 1 like this, and 1, 0, 0, 1. So this is the regular expression, the reversal of the language, and where we are going to define the regular expression for the reversal of the language as like this. Let us consider the regular expression for the given language is this, and the regular expression for the reversal of the language is this, which are both same. So we can say that the reversal of a regular set is also the regular. The next property is the sixth property. Consider this. The closure of a regular set is regular. How we can say that? Let us consider a language L which is having the strings like this of odd length. Make a note, that is excluding null. Then the regular expression for this one is this. That is regular expression of the language is A of AA whole star. Then it is defined as L star, that is the closure on the language is A double A like this. So we can define. So all these strings excluding null. So how we can define this? We can define this as like this, which is also a regular expression. That means the closure property on the given language generates another expression that is under regular. So this is also proved. So the next one is the seventh property, that is the concatenation of two regular sets is regular. The concatenation means what? The combination, that means union. Next, the regular expression is defined on 0, 1, that is on the sigma, which is defined as 0, 1. So for that, the regular expression is 0 plus 1 whole star 0 and 0, 1 of 0 plus 1 whole star. Then the for the regular expression 1, the language becomes like this. What the language has to be depending upon the regular expression? The language has to be defined like this: 0, that means like this, 0, 0, 1, 0, 0, 0, 0, 1, 0. The combinations of zeros and ones along with 0. That means at all parts 0 must be there. So the set of strings ending with 0. That means the set of strings ending with 0. Next regular expression is this: the strings has to end with 0, 1. Sorry, beginning with 0, 1. See, for that the language is defined as 0, 1, 0, 1, 0, 0, 1, 1. So these are the two languages that are defined according to the given two regular expressions. On them we are going to make the operation as the concatenation. That means how we can concatenate. See, concatenation is the process of combining each and every string of a language with another, with all the strings of next language. So 0 has to be combined with this, this and this. See, 0, 0, 1. Next one is 0, 0, 1, 0. And next one is 0, 0, 1, 1, as we got it. Next, make a note, this string has to be concatenated with all these three. The string is 0, 0 in L1. So the first string of second language is 0, 1 along with 0, 0, 1. Again, the second string of the second language is 0, 1, 0, which has to be concatenated with the second string of first language 0 1 0 1 0. Next 0 0 0. Like this, the concatenation is performed on the strings. That means with each and every string of first language has to be combined with all the strings of second language. Then only the concatenation process will finish. Now we are going to see whether we can define the regular expression for this concatenation or not. See, the regular expression is of like this. That means the strings that are starting with 0 0 1. See, in all the formats, the strings are starting with 0 0 1 along with the combinations of 0 and 1. That means multiple combinations of 0 1 1. So this is also proved on the concatenation of two regular sets is irregular. Now we are going to see the identity rules of regular expressions are like this, where the given RPLQ, where we know the definitions of all these is in previous. Now see, the closure of null set is null. The closure of a regular expression with concatenation is the closure of R and R. The closure of regular expression is R closure. Next one is PQ closure into P is P of QP closure. Next one is AB closure is equal to A closure, B closure, whole closure. Next one is this can be written as like this. That means A closure, B closure, whole closure, or A closure, B closure, whole closure. Next one is A star, BA star, and star. Instead of mentioning the star mark as the closure, we can define it as the star also. Next one is the union or the concatenation of a regular expression with a null set or a null set with a regular expression gives the regular expression. Next one is the concatenation, that is RE, that means epsilon R is R. That means null set of along with the language or language with the null set gives the null set. That means the intersection. Next, two combination of two regular sets gives another regular set. Next one, L of Mn gives Lm and Ln. The left distributive law is applied on here. Next one is M plus N of L, that is Ml, Nl. The right distributive law is applied here. Next one is E plus, that means epsilon plus R closure is equal to epsilon plus R closure R, which gives another regular expression as R closure. So, and another three important closure laws are like this. Null set closure gives another null set, and this is already defined closure of closure. That means R closure into R closure, which gives another expression closure. Next, R into R closure gives R closure into R. These two are important. See, these are the identities that are related to the regular expressions. Thank you, my dear students. We are going to continue in the next session with another topic.